Hello, my name is Miriam Garab, and this is my Module 2 Mastery assignment. The topics I will be covering in this video are algebraically using the definition of a derivative and using the chain rule. When algebraically using the definition of a derivative, it's important to remember the actual definition, which is the limit as h approaches 0 of f of a plus h minus f of a over h. It's also important to remember that the definition of a derivative is equal to the standard derivative notation, which is f prime of a. So when using the definition of a derivative to find the derivative of the function 2x plus 3, you see by my work that after adjusting the function to the definition of a derivative, after simplifying and canceling out terms, we find that the derivative of this function is 2. So in this next example with the function x cubed minus x plus 1 at x equals 3, what we're doing is finding the derivative of f of x, and then after finding the derivative of f of x, we are plugging in 3 for x to find the derivative at specifically that point, and the answer is 26. Moving on to using the chain rule to solve for the derivative of a function. When using the chain rule, it's important to remember that the derivative of f of g of x is equal to the derivative of g of x times the derivative of f of g of x. It's also important to remember that you can do either or first because multiplication is commutative. So when using the chain rule for the function given f of x equals sine of 3x plus 1, the first step is to find the derivative of 3x plus 1, which is 3, then to find the derivative of sine of 3x plus 1, which is cosine of 3x plus 1. Multiplying those two together gives you your answer of 3 cosine of 3x plus 1. So it's important to remember when looking at a function such as this one that the standard form of a function of e is e to the power of x. So in this case, 5x squared is our g of x. So after finding the derivative of g of x, then after finding the derivative of f of x, which in this case is the same as the original function, we get the derivative is 10x e to the 5x squared. So when dealing with roots, it's always better to rewrite the root into exponential form, which is what happened in this case. So after finding the derivative of g of x, which in this case is 4x minus 2, and after finding the derivative of f of x, which in this case is 4x minus 2 to the power of 1/2, we get that our derivative of the function is 2 times 4x minus 2 to the power of negative 3 over 2. Thanks for watching my video.